Excellent, thanks.
All right. I think it should be recording now. All right. Thanks for reminding me, Jason. Okay. All right. I hope everyone can see my screen. Can? Okay, great. All right, so I think a lot of you on the meetup site was able to access the GitHub repository for this meetup this evening. The code that we'll be going over is there, as is the requirements.txt file that lists all the package requirements for this meetup tonight. At full transparency, I did not make a specific virtual environment for the code. I was a little bit lazy. So there are quite a few packages there that actually aren't used in the notebooks. But certainly those that are, those will be the package versions that ran on my computer. Okay, let's see. All right. I can't see all of you in the gallery view, so if there's questions or you guys need to stop me, please raise a virtual hand or you can make a chat. Okay. So we're going to talk about scaling tonight. I don't know how many of you have ever really run into scaling problems, but I think in every data scientist's life, eventually you get to that point where you're doing more and more, you're using more and more data, and things are getting big and it feels like your laptop is getting smaller, and you really start thinking about scaling issues. And when I think about scaling, I think about really two different ways to do that. The first way is to get a bigger computer, right? You can buy a new laptop, or an extension of that is to actually start using cloud infrastructure to run your algorithms, do your transformations, run models. So that's kind of the first way of, or the first tool that you have for scaling. The second way is to think about optimizing your code for scale. And Dask is one of those ways to do that, and we'll be talking about that tonight. I'm sort of evaluating right now some different ways to scale, and Dask is one of those packages that I'm using to evaluate. So you can also use both of those together. If things are getting pretty crazy in your data science life, you can also use clusters, large EC2 or Azure Compute instances, along with some of these scaling packages. And really what the packages do for the most part is they leverage the power that you have in your CPU, which most people have multiple cores in their laptop's CPU. I did a little bit of research, keep me in check, but it looks like it was the late 90s to early 2000s when more modern computers started having hyperthreading and multiple cores within their central processing units. So nowadays we have multiple cores that we can leverage, and a lot of data scientists starting out probably don't think about that very much. They're running their code very much in series. But you get to the point where it takes a long time. So we're going to talk about some strategies to kind of get around that tonight. All right, so two things you kind of want to think about when starting to what I would call put together a scaling strategy. So is your process, your algorithm, your machine learning model, your regression, is it CPU bound or memory bound? And what does that really mean, and how do you know? Well, the quickest way that I know how to do that is to actually monitor your system while your algorithm is running. For Windows users, that's done through Task Manager. For Mac users, it's done through, I think I had it open here, the Activity Monitor, which is in your utilities. Which I have mine open right here, and you can see CPU and memory across the top. You can also go up to the window, and you can select this option, which is CPU usage, and it opens up a little window, and you can see the different cores that are running on your computer. You can also, if you have a terminal, you can issue top, and it will provide you with all the processes that are running on your computer currently. It's a little bit harder to monitor because it doesn't give you sort of a graphical representation of usage, but it is a way to monitor usage. All right. So the DASK documentation, which I think is actually quite good, really provides some great guidance when it comes to understanding if your process is CPU bound or memory bound. I gave a little snapshot of the page within the DASK documentation and their tutorial that talks about types of scaling, and it's really just what we discussed. They also provide some what I would call sort of next steps once you determine is my process, does it need more CPU or does it need more memory, or potentially both, right? When we kind of go over code, I mean, one thing to really think about is the number of cores that your computer has, and really leveraging that power when you're starting to talk about scaling. And I think that's a lot of what we'll demonstrate this evening. All right, so for the code tonight, I wanted to include a little bit of information for you guys about what I'm personally using to run this code, such that when or if you would like to do it on your own, you have some specifications of what I was using, such that if you can't get it to run or you're running into some errors, it can give you a little bit of guidance. So this is a snapshot of my personal Mac. And the different specifications that I'm running, including my processor and memory. I use Python virtual environments, as we discussed in our pre-meeting. So I created it with V, E, and V. The requirements, again, are in the text file within the repository. I'm using Python version 3.7.6. Of course, I'm also using a Mac. All right. Okay. All right, so sorry, I was just checking the chat there. All right, so the basic concept of Dask is to actually split our data and computation up across our computer's CPU. That's really basically what we're trying to do. And Dask is installable, so it's Conda installable. I know some of us are very much against that. Charlie's a big fan, just kidding. So you can do a Conda install. You can also do a pip install. That's what I did for the demonstration here this evening. Or you can also install it from the source. You can clone the repository, navigate to the Dask directory, and run the setup file. Okay, Dask very broadly can scale from your laptop up to a cluster of machines in the cloud. Talking about Dask and using it on a cluster is really beyond the scope of what we're going to discuss here tonight. But it is definitely possible. I think your data have to be pretty big, and I think it has to be a pretty computationally heavy task if you're using Dask with a cluster. Dask also has the concept of arrays and data frames. So as we mentioned a little bit in the pre-discussion, it integrates pretty heavily with NumPy, also Pandas, which we'll talk a lot about tonight, and then scikit-learn. It has several ways of distributing tasks and scheduling. Dask Delayed is probably the most widely used task scheduler. Task scheduling is kind of like if we have a task such as we want to run a function, we want to do a transformation on our data, we potentially want to train a data set. That's kind of what I mean by task. And we can schedule that to run in parallel on our laptops. Dask also, very interestingly, and I find this pretty interesting, has a machine learning library kind of built in. It seems like it's built on top of scikit-learn, so I don't know if it really uses scikit-learn in the back end, but it definitely has similar syntax, I think, to scikit-learn, and we'll look at a simple linear regression tonight to talk about that. Now, scikit-learn has a method called joblib. I don't know how many of you have used that, but if you've ever serialized a model like with Pickle, another way to do that is through joblib. It also has a task scheduler as well, and Dask can use joblib to schedule those types of jobs. All right. So this is a snapshot of the documentation for Dask. I've included the link up here at the top. But I just wanted to include this because you can really see that one of the biggest advantages, I think, of Dask is that you have all of the same methods. Well, I won't say all, a subset of the Pandas methods available to you for a Dask data frame. So if you wanted to compute a mean, if you wanted to do a log transformation of your data, if you wanted to do like a .describe method, all that is available in a Dask data frame, but it is limited. Pandas is arguably more flexible and more powerful, but it's also slower. But I personally really liked the feature that the syntax felt very familiar. So it seems like I could kind of quickly get up and running with Dask, which is a big reason that I'm considering it for my project. All right. This is really beyond the scope of this talk, but this is a list of other parallel processing methodologies and packages that are, I guess, Dask-like, if you will. That can be used to make your code more parallel. Multi-process is probably one that some of you have used, but there are some others that are out there. Modin is one that has been talked about recently. Panda Parallel, I don't really know how to pronounce that exactly, but that's one we've kind of discussed on Slack using. These packages seem pretty streamlined. You know, they kind of have sort of a reputation of being a little bit more one-liner than something like Dask. I have not really explored these to any great extent, but I really wanted to mention them in our talk this evening. Okay, wanted to talk a little bit about when you're doing Pandas transformations and you have something to do with your data in a data frame, what are some of the methods that are a little more scalable and faster, and what does that hierarchy kind of look like? So one thing to think about is, first of all, vectorization of your Pandas data frames. So doing some sort of function or transformation on an array or a vector of data is going to be much faster than, say, iterating over the rows of a Pandas data frame. And there's a lot of blogs out there. I included one. There's some others that really compare iterations of data frames using a .apply method, .intertuples method, iterows method. Iterows is considered pretty slow. Intertuples faster. And the reason for this is the way that it holds the data in memory. Intertuples will hold the data as a tuple, but of course you have to access the different elements as a tuple. So if you're working with quite a few rows or columns, I mean, then your code might get kind of weird if you're always accessing it, you know, by an index. Certainly a .apply method is going to be faster. So when you have an operation to do on a Pandas data frame, you're doing pilot code, but you know later on it's going to have to be scalable. Then these are some of the things you should be thinking about. If you choose to do something like iterows, you will have to know later on that things are going to get pretty slow pretty quickly. All right. So also just included a quick sort of link here. That was a blog that did some of the comparisons that I just talked about. So this one looped over a Pandas data frame, and they give the average runtime and improvements for each of the different changes and methodologies. Now, I haven't really done this type of experiment myself on my own data frame, but certainly there's a lot of information and blogs out there about something like this, and it will give you some guidance as to what you might want to really start doing in your Pandas transformations. All right. Any questions so far? I'm going to check the chat here. All right, nice. Got a Stack Overflow link. All right. Okay. Now let's go over to the code. So this is, of course, just my Jupyter notebook that I have open in my virtual environment. This is the exact same code that is available on the repository. So we'll open the requirements.txt file. Of course, I think all of you might be familiar with this. These are the different packages that I have loaded on the current virtual environment. I used 2 data sets for this code. So I did hard code them to my path in the repository, but I included the CSV files in the repo, so you'll have to change the path to the data if you want to run this code. The first one's called lap times. Both of these came from Kaggle. Lap times is actually Formula One race data. And then rwq.csv, which is actually red wine quality. So those are the 2 data sets. It was pretty random choice for these 2 data sets. So they're completely unrelated. Let's see. Okay. In the README file, I also include some resources for everyone. I think some of these are listed in the deck, but there's a few different links here to some blogs and some tutorials that I thought were pretty relevant for our discussion here tonight. Okay. So we're going to work through 3 examples, and then we'll just run the code, and then we can have an open discussion. So for each of the examples, I really tried to do a learning objective for the group, like what is my vision for what you might get out of this code. So for this first example, the learning objective is to demonstrate parallel running of functions. So there's a few concepts that I want to go over with the group. So the first concept is Dask clients, which is a method within Dask. This method provides, I'm sorry about the typo there, what they're calling an entry point to Dask distributed. So basically this sets up a connection to your cluster, your processor, and allows you to submit jobs. I sort of conceptually thought of it like a connection string to a database. Whether it's truly like that, I don't know, but that's sort of what came to mind when I was reading about it. The next concept, secondly, is Dask distributed. So this is the task scheduler for Dask. It coordinates all the tasks, functions, jobs across the cores or nodes that you're running. JobLib, also, we've mentioned these before. It's part of scikit-learn. It has functions for saving your models, kind of like Pickle. Also has task scheduling. Dask integrates heavily with scikit-learn, and I include the JobLib link for the Dask documentation there. And then lastly is this concept called Dask delayed. This is a kind of decorator for functions that allow for delaying them or making them what they call lazy, such that they will run in a parallel manner. The basic concept is that instead of running our functions serially, like we run a function, we get the output in a Pandas data frame, we run another function, we get the output. Instead of doing that, we're actually going to send all our functions to our cores all at once. They will run together, and then we get the result back together, and it will speed up our process. All right, so I'm going to run this in real time. We'll probably have an awkward silent period while we're waiting. But first, of course, importing packages. And then I'm going to import the data. So the data is imported. We're using lap times in this example, so the Formula One race data. And then we converted it to a DAS data frame, which is very simplistic. It's one line of code. So data frame Dask, it's a variable that I created, is just DD from Pandas. And I imported Dask data frame as DD right here. All right, then we instantiate our client, which we discussed previously was our entry point to be able to send tasks to our processor. And then I have a few functions here, which honestly I just made up. So in the Formula One race data, there is a column that gives the lap time for the car. And it's listed in minutes, seconds, and milliseconds. And it's a string, and it's separated by a colon and then a dot to separate the minutes, seconds, and milliseconds. So I really just wrote a function to separate these strings. So I wrote the first function actually separates it at the period, and the second function separates it at the colon. The last function actually just prints the results of the two functions. So I'm going to run that. And then we're going to run this in parallel. So I'm using also the magic time function in Jupyter Notebook that I think some of you might be familiar with. It will time the runtime of the cell. All right, we'll wait for that to run, but of course, spoiler alert, I've already included in a comment that this actually takes 3 minutes to run.
Lindsay, this is Betty Ann.
Yeah.
So to back up to one of your earlier cells where you defined n workers equals 4.
Yes.
Is that reflective of like 4 cores you have on your Mac, or is that an arbitrary number?
I would say, yes, it is reflective of the number of cores on the Mac. This is a quad core machine. I think there is some guidance in the documentation on sort of how to choose that. I did not go through the process of changing that number to see how it would change the runtime. I kind of suspect it wouldn't, and we'll sort of get to why I think that later, but yes, that is reflective of the number of cores.
So if I were to do something silly, like if I had 4 cores and decided I had 8 workers,
yeah,
does that work, or will they just like swap in and out and said, well, you said 8, I only got 4, so they keep swapping in and out?
It's really funny that you mentioned that, because I thought maybe I should try to put a ridiculous number like 100 and see if I can break it. And I didn't, and you asked the question.
So I'll do it then.
I actually don't know if it would break the code or not. We can try it here, and we can try to break it.
I'll see what happens and report back.
Okay, perfect.
Thank you.
Sure. Any other questions while we're in our awkward silence period? Oh, I just saw your chat now. I'm sorry, my chat is not open all the time, so I can see everything I'm doing. So I'm sorry if there's awkward delays.
Yeah, no worries about that. I mean, it gave me a chance to try to fill up the awkward silence.
Yes, thank you. I appreciate that. You're like my wingman.
Sure.
I wonder actually if this is going to take longer while Zoom is running.
Yeah, you know, when you showed us your top and, you know, the processes that were running, Zoom was taking up most of your CPU at the time.
Yeah, so I suspect it might take longer, actually. This is so exciting. We're doing stuff like in real time. It might break.
Lindsay, if you show your activity monitor, it'll show for Python?
Well, not right now. We're not running in parallel, but let's see what it says. That's a good point. Oh, it's actually, well, I mean, it's kind of running, I see. That's interesting. See that it's spiked right here, so. Okay, it finished. Okay, so it's about the same time. When I wasn't running Zoom, and I really didn't have anything else running, just Chrome and some terminals. It was a little under 3 minutes, so it took a little bit longer. Okay, so next we're going to try to run this in parallel. So this is where we use Dask delayed. So I named the variable x is equal to delayed, and then I have my first function, which is a split columns 1, right? Dask delayed, y is delayed, split columns 2, and I pass it my data frame. And then I have the z function, which is just to print the results, right? So this delayed kind of decorator of sorts will actually make the functions lazy, and it will send them and distribute them across the cores. Okay, so we're gonna run that. That was very quick, but actually we didn't do anything. So in Dask, what you have to do is you have to call a compute method in order for it to actually run. So that's here. Please ignore this error. We can talk about that if we want. I actually looked this up to institute this client scatter method. I didn't really get it to work very well, but I guess it does throw an error if it thinks that the data is a little bit larger than it should be. But this isn't really a very large data set. So we're going to enter into an awkward silence period again while we watch this code run.
Hey, Lindsey, this is Blake.
Like,
The delayed decorator,
mhm.
can you talk a little bit more about what's happening behind the scenes?
Yeah, so from what I've read, it actually, what it does is it sort of stages your functions. And when there's an available spot, I guess, for your CPU to take on a task in sort of a thread, it sends it there, and it sort of does it in a staggered way. So what it's doing is it's actually sending these functions across my processing unit, as opposed to like letting one run and finish and then letting the next one run and finish, etc.
I'm trying to differentiate between just sending the instructions or the functions versus the compute that you then executed.
Yeah, so the delayed is the scheduler. The compute actually sends it, if that makes sense.
Got it. Thank you.
Of course, there's also another spoiler alert. I say that this runs in half the time here in my comment section. And it just about did. So 1 minute, 54 seconds. It was running 1 minute 30 when I didn't have Zoom. So it's kind of interesting to see how Zoom affects this. But yeah, it did speed it up, right? So you can imagine if you have some really compute intensive functions, then this can really decrease the time to run those, because I think we've all been in situations where we're either trying to train a model or we're trying to do a transformation and it's taking a long time, and then we have to wait and it didn't do what we thought we wanted it to do. So we had to make a change, and then you wait again, and that gets really annoying, right? Of course, it is best practice to obviously do that kind of thing on a smaller data set. But there are situations where you can't do that. So this book can really help. It can also obviously help in production, right? Compute resources in the cloud are expensive. And if you can cut down your runtime substantially, that can save you some money. Okay. So Dask also has a really interesting visualize method that can basically use like a DAG to help you visualize the functions that you've run. And here we can see we've had 2 functions that ran, and they went to print results, and then we got the output. This is obviously pretty simplistic, and I think these can get pretty complex. I did want to mention that I had to install GraphViz to get this to work. So if you're having some trouble with that, I use Homebrew some as a package manager, and I did a brew install of GraphViz in order to get this to work, just an FYI. Okay, so in the end, our client, sort of our portal entry point to our processor is open, and we really want to close that. So we just issue client.close or whatever you named the client, and then we're done with this first example. All right. I'm actually going to go ahead and close that window. I'll leave. Okay. Next is example 2. So this is going to be a short example, also full transparency. This is some sample code that I partly used in my class at Lipscomb, and I sort of retrofitted it for this meetup. But we won't run all of it, but we will run a little bit at the end. And really the learning objective here is to almost give like a negative example of Dask, because one thing I really wanted to point out is that Dask might not always give you performance increases like you might expect. And we'll talk about that kind of at the end. So our learning objectives here are to understand the terms of multiprocessing, multi-threading, and multitasking. And I found this great blog that I think explains them very well. This is copied from the first part of the blog. Multi-programming is your computer's running more than one program at a time, like running Excel and Firefox simultaneously, or any other program. Multiprocessing, computer using more than one CPU at the time, or your sort of virtual CPUs in your cores, right? And then thirdly, multitasking, tasks that are shared by a common resource. And then multi-threading is also an extension of multitasking. So our second learning objective is to demonstrate conversion of Pandas data frames to Dask data frames and the application of methods to those. We saw that a little bit in the last example, that one line of code of how we transform a Pandas data frame to a Dask data frame. I'm pretty sure that you can when you do an import of a CSV file, or if you read data from a database as well, you can import it directly as a Dask data frame. You don't have to do it as a Pandas data frame and then transfer that to a Dask data frame. Lastly, understanding why Dask might not be preferable to Pandas in some cases. And this is actually made pretty explicit in their documentation, and I've seen it personally in my code. So we'll see that here in a minute. All right. So we're going to import our packages here. We are going to use the lap times again. And I didn't do this in the last one, but we'll look at the data a little bit. It gives racer ID, a driver ID, the lap, what position they were in, the time. This is the column that we actually split the string in the last example. And then this time converted to milliseconds. So I want to go down to the end. We're going to skip the multi-process examples, but they are available to you if you want to compare and contrast the use of multi-process and Dask. But we're going to go down to the bottom with Dask, and we're going to convert our Pandas data frame to a Dask data frame. And I have a few functions here. So the first one is to compute the mean of the Dask data frame. So the syntax is data frame, you give the data frame name, which I've called data frame underscore Dask, the column name, and then dot mean, which is really exactly the same as Pandas, which I think is what makes this really interesting. So I have also just the same function, but for a Pandas data frame. And then also the maximum of the column, so the max number that's in the column. So we're first going to compute the mean Dask. So this is the Dask data frame, and so the mean of the column is the output. It gives it in a scalar, so it doesn't print it out. But that took 2.7 milliseconds. Pandas actually took like a third of the time. So that's pretty interesting, right? That's kind of unexpected. I don't really have a great explanation of why that is underneath, but the documentation is very clear that when you have small data sets that you really should use Pandas and you shouldn't use Dask. Now, it doesn't say what small data sets are and how small is small. It does not provide any guidance as to a threshold. But I think this is something important to keep in mind when you're dealing with your data sets. If they are fitting in memory in a reasonable way, probably your best bet is to stay with Pandas. Now, if you think that your data might grow over time, then even if you're not seeing performance gains with Dask right now, it might be preferable for you to implement Dask within your code, knowing that the data could grow, X amount over time. Of course, a little bit of this is a little bit foreshadowing, but obviously the max time is also the same. We do not see a performance gain in calculating the maximum value for that particular column. Where they talk about this is actually in this link right here. One thing I really love about Dask is that they have some really, really nice, clear examples that are in a GitHub repository. And this one that's providing examples around data frames is quite good. I think I actually have it open and it's right here. So I would encourage you, actually, this is another one. Okay, here it is. This is the main repository. And you can see they have different examples, an overview, an example of Dask delayed, a lazy example. There's something called bag. I haven't read much about that, so I'm not very up to speed on bag. A data frame example, an array example, distributed example, and a couple machine learning examples. So I would encourage you to check this out. And they talk about, in this data frame example, when you should implement Pandas and when you should implement Dask. All right. Okay, we are actually going to close this example and we're going to go to our last example. So this is a little bit more in the machine learning realm, although I don't really consider regression necessarily machine learning. That might be a little controversial. But Dask does have machine learning methods built into it. We'll look at just a simple linear regression with our red wine quality example, where we are regressing with the pH of the wine. So our learning objectives for this example are to, firstly, really just basically understand Dask ML syntax for a linear regression, become a little bit more familiar with joblib. Thirdly, understand how to implement a simple grid search using Dask. And then this is kind of a bonus objective that I hate to not be excited about Dask, but I'm almost more excited about this. I don't know if anyone out there has ever used Pandas profiling, but if you have, you'll never use .describe again. I think it's totally amazing and I get really excited about it. So we'll go over that. Okay. All right, so in this first section, we're going to import our data as a data frame and then create a Dask data frame, which we've already done a few times tonight. So I'll run that. Import our data. So I'm now in the RWQ, or red wine quality.csv data that's in the repository. And then here, get ready for the magic. So we're going to run this profile report with our data. We're going to title it Profile of Wine Quality Data and run this. It's got these little progress bars, which I love. And then we're going to have a small awkward silence again. Okay. I don't know if anyone's ever used this before. If you have, stop me, I'm getting giddy, but this gives an overview of all of your data. So we have just basic statistics around the data if you scroll down. Then there's the different variables that's in the data. So this is red wine quality data. So of course, acidity, sulfites, and things like that are in there. It gives a distinct count, the percent that's unique, the mean, min, max, number of zeros in the column, a little bit histogram over here on the side. I love that. It does that for all of the different variables. So I'm scrolling down. And then look at this, interactions, and you can like click on stuff, right? Citric acid and pH, and it makes a little heat map. It's wonderful. Let's see. And then correlations. Sorry, I'm having a hard time scrolling because, okay, so the correlations, you can look at different correlations within your variables. So if you don't want to include like covariates in your model, you can quickly ascertain, are there different correlations between them? I think that's amazing. It gives a histogram of all the missing values and a sample of the data. So the first rows and the last rows. The most frequent duplicate rows as well. And if you scroll over, it gives a count over here on the side. And I think that's it. So Pandas profiling, totally amazing. Little bonus treat for tonight. I got really excited about that. I don't know if anyone else did.
Actually, Lindsey, this is Betty Ann. Actually, I did. That's pretty awesome.
It's totally awesome. All right. Okay, so
thank you.
Yeah, absolutely. Definitely check that out. It's just one line of code. It's in the repository, but certainly it probably does a lot more than that, but that's really all I've done with it. And I've gotten so excited about just that little bit. I haven't really done anything else with it. Okay, so we're gonna do a test train split of the data. Now we have a training data set that is a little over 1,100 observations and a test data set that's 480 observations. So it's a common 70-30 split. And then we're going to make those Dask data frames. Okay, so I say in this next section that this is not really a scaling example. It kind of is though. So one thing they talk about in the documentation, and I think this is a really fair workflow, is to train on kind of a smaller data set. And then when you want to run predictions, then you scale up pretty substantially. So that's kind of what we're going to demonstrate within this section 2. So within just a basic linear regression, and I really did not spend any time truly making a linear regression. I really just threw some variables at it and that's it. So it's not a great regression, but the point is to really demonstrate some of Dask's regression capabilities. So what we're going to do is actually predict pH from the acidity, volatility, citric acid, chlorides, other types of red wine quality measures that we have within the data set. All right, so I really just made here lists of my different variables and then the predictor. Okay, so this next section, of course, I think a lot of you might be familiar with when you pass like your variables and your outcome variable to a lot of machine learning methods, they typically have to be in arrays. And this is what we're doing here. Now the Dask documentation actually has this .values method, which I left the line of code here, but commented out. This didn't work for me because it doesn't return like the chunk size in the array, and the method actually needs that. So this is kind of a known error that I found certainly in the GitHub issues, and then it was also something on Stack Overflow about it. But I actually had to use this toDask array method. So let's run that. So that gives us our X and Y values for the linear regression.
Hey, Lindsey, this is
Yeah.
Betty Ann again.
Sure.
Is it really seen as a bug? The reason I ask is maybe Dask, because maybe it's natively lazy, that it doesn't actually load it into memory, so it doesn't actually know the length.
That could absolutely be true. I did not read that in the comments, but that's a really good point. It might not be a bug. I will say it did use the dot values method in the examples, but then when I ran it, it failed because of that.
Right.
So the 2-dask array does actually give the chunk size of the array.
Gotcha.
So I don't know, it worked for me that way instead of using the dot values method, but that's a great point. Okay. Any other questions? All right. So here, just very basic, we are going to run a linear regression. So Dask, as you can tell, has very similar syntax to what you would find in like scikit-learn. And the linear regression is just linear regression. You can give it different arguments. Here, I gave it a solver of gradient descent. There are some other arguments that you can pass, but we're doing something pretty simplistic here. And then we just use this linear regression method to fit our X and Y data. So I'll run that. Okay. And then we can predict our X values and give an R² scoring of the prediction. So it's 0.64, which is not great. I will say I spent some time trying to make a graph from the Dask output of the predicted values versus the actual values. I will say I had a really hard time actually accessing the values. And there's not a really clear area within the Dask documentation on how to do that. I do think that's a little bit of a pitfall of Dask. But however, you know, for a training exercise, you know, when you're trying to develop, you probably want to investigate and look at your data a lot and look at what it's predicting versus what the actual values are. In a more production setting, you're probably not looking at that as much. So I suspect that's the reason why there aren't a lot of great ways to access those values. They are accessible in the array, but you have to pull them out and then you load either like Plotly or Matplotlib or something like that to plot those values. It wasn't quite straightforward, and I honestly just kind of ran out of time actually. But just so you know, that wasn't a super easy thing for me to do. Okay, there is a params. We can get the params of the linear regression that we just performed. And then, of course, like any linear regression or any type of regression or model, we want to do a test on our data. So the predictions obviously come out in an array. And here you can see there's the chunk size as well, which is what we wanted. Okay, so this kind of simulates going through a training exercise, you know, with our data. So let's say we're ready to put it in production and we want to scale up and we have a ton of data that we need to use. So Dask ML has this method called parallel post fit. And that is used to kind of wrap around the model, let's say, such that it serializes the running of your data through the client. So we have a client here. It has similar arguments as we've seen before. I have a few more here. Number of workers, I really just put 1. There's also a memory limit option that we could have added before, but I didn't have. So I'm going to run that and create a client. You can also call the client and it will tell you information about the client you're working with. So here we just created a variable and we called the parallel post fit method, passed it our linear regression and our scoring methodology. So I'm going to run that. And it's really just the same. Instead of calling the predict method only, we use this variable in front of predict and it will run our predictions again. So this is a way that you can use the client to scale your predictions later on after you've already trained your model. Okay, lastly, and I'm going to go over this very quickly because it was a little bit of a later add-on, but Dask does have a grid search capability. This is actually just, this code specifically is straight from the documentation, but I thought it was interesting to at least review. So it uses joblib to do a parameter search, this time for a random forest regressor. So basically you put in a parameter of a parameter grid of different hyperparameters and the ranges that you want to search. And then we instantiate a random forest regressor here. And then down here, we actually pass this param grid right here to the grid search CV method. Now this is using Dask, but if you are familiar with scikit-learn's grid search methodology, it's actually really using scikit-learn. Dask is sort of like cheating and using it. So it's very similar. And I think this was important to point out because if you have very large training jobs and you want to do pretty large parameter searches, this is a way to do it through your client and utilizing your cores and your workers. Okay, so we can run that. And then we run this bottom part. That's actually taking a little bit longer than I anticipated. Okay, so what it returns to you is the most optimal grid search parameters for what you passed to it. And again, as you can, I think, imagine, if you have a really large training set data, this can be pretty computationally intensive. So this is a way to do those hyperparameter searches in a more scalable way. Okay, so we will close our client. And that ends our demonstration. So I think we're actually right at an hour. I can't believe I talked for exactly an hour because I did not practice this. But I'll stop sharing. And really, any questions or open discussions? Do we have any really talented Dask users out there that would like to sort of share with everyone? So yeah, just kind of open the floor.
So this is Betty Ann. I'm not a Dask user, and that's why I showed up. So Lindsey, thank you so much for that, for your insight and your work, and for sharing that with us. I'm pretty excited to try it. Thanks.
Yeah, absolutely. Thank you. Anybody else? Everyone's so quiet.
Hey, Lindsey, I put a message in the chat, and I was just wondering earlier when you had set the number of partitions to 8.
Yeah.
You've done a lot of sort of large-scale group buys, and do you know how that would affect performance there?
So I think that, and I don't know this for sure, but my sense is that it depends on the size of your data, right? So yeah, large-scale group buys can be slow. The reason that I chose the splitting of the strings, it was actually intentional. It is slow. I mean, it's 3 minutes. I guess that's not really slow in the grand scheme of things, but it's slow enough that we have some room for improvement, right? So yes, what you're talking about, I think, is a slower type of computation. And I think if you are using the client with 8 partitions on your local machine, I think it's empirical, to be honest. I think you should try it, compare it to your Pandas operation. You know, there might not be any performance issues. And I don't really have a magic number for how big the data have to be in order for Dask to actually cross the threshold and be faster than Pandas.
And I was kind of curious, if you were to say like double the number of partitions, would you see a linear, you know?
I don't know. I did that and it didn't work.
It didn't work, or it didn't change?
I'm sorry, it didn't change.
Okay.
So it was kind of a bummer, and I didn't feel like that was exciting to share. But yeah, I did do that, and it really didn't do anything for me. But again, the data that I demonstrated here tonight is on the smaller side.
I see.
Which contributed to the reason you were able to hit 1 hour exactly.
I guess so. I'll remember that next time. It was a happy mistake. Not a mistake, I guess.
No, it was perfect planning. Good for you.
All right, anybody else? Any other questions or comments?
I was playing around with the workers because I think Betty Ann asked that question. And I went from 4 to 16 and saw maybe a 2-second difference.
Okay.
I think this computer has 16 cores, so should have.
Fancy.
Yeah. I didn't know until you started playing around and showing us the activity model. I'm like, I never even thought what this happened.
Awesome.
But anyway, so I don't know if there's I know a lot of times other auto ML stuff will never go more than 4 workers at a time, things like that. So I don't know how much you gain after that.
Yeah, I don't, to Jason's point, I don't know if it's linear. I suspect that it's not.
Yeah.
Probably like the square root of 2, or square root of a number of workers or something.
Right.
You start losing benefits of the messaging. Yeah.
Yeah, absolutely.
So Lindsey, after doing the work for tonight, are you going to go with Dask, or are you still evaluating?
I'm still evaluating, but based on the structure of my projects, it would be easy for me, I say easy-ish, for me to implement Dask. And honestly, that's part of the reason that I'm thinking of going with Dask. It just contextually, the nature of what I'm working on seems to fit Dask better than some of the other methods, which, just to be clear, I haven't really done a lot of pilot code with, only really read about. The Modin package that was listed, which is out of UC Berkeley, I think that's newish. Is that right, Jason? I know John was one of the first ones to alert me about that.
Yeah, and I looked at it actually when you posted that link, and it does have an integration to Dask as the backend.
Okay, interesting.
So.
It almost feels like some of these packages are just, they're like using other stuff, but putting a fancy name on it, and I don't know.
Convenience wrappers, right?
Yeah. So yeah, I think that I will end up going with Dask. That is true.
And all the options that you posted, those were, I won't say free, but with limited resources versus a bigger pool if you had unlimited resources.
Ask that again. So do they need unlimited resources?
Were you working on the set that you sent or posted? I'm assuming that was with a very constrained, limited amount of resources. Would it have been a bigger list if you had unlimited money?
No, I mean, really, it's just time. I mean, I am leaning on my slick Google skills and also my data science friends who I tell them that I'm thinking about scaling. What do you know about? And that's really where that list came from, mostly word of mouth and me sort of looking at blogs and things. I don't know that it's exhaustive. I would be surprised if it truly is. I mean, ultimately, like from a resource standpoint, it really only makes sense to implement, one scaling methodology. It's kind of like what I was talking about in the beginning. Are we CPU bound? Are we memory bound? What's the strategy for implementation there? What would probably work? And then kind of making the decision to sort of go with something else.
Gotcha. Thanks.
All right. Any other questions or discussions this evening?
I guess one last thing, Lindsey.
Yeah.
Have you experimented with using, do you know if there's any wrappers or integration with like TensorFlow or PyTorch?
I don't know.
Okay.
I have not looked at that. That's a great question. Since what I'm using it for doesn't use that, either TensorFlow or some kind of machine learning, I haven't investigated that, but that's a really good question. I don't know. I'll investigate that and Slack you.
Yeah, we'll both look at it.
Perfect. All right, guys. Well, I hope this was useful for everyone. I tried to make it a little bit introductory, but also get a little more into the intermediate for those of you who might have done scaling or used Dask. So I hope it was useful and at least a little bit challenging. You guys have the code, it will stay there, so feel free to copy it and steal it if you so desire. But I really enjoyed seeing everyone tonight, and thank you for your time this evening.
Thank you so much for doing this.
Yeah, absolutely.
I'll definitely down some more. Definitely.
So I did record this, and I think the recording, I'll probably lean on Jason to kind of help get that posted, but we'll let everybody know when that's available.
Also, just wanted to say, nice to see you all. I haven't been out of the house in months now, so it's good to see people.
It's good to see you too, Betty Ann.
Thanks. Stay safe, everybody. So, you know, some of you know I work in healthcare, and so we're seeing a resurgence. I mean, just like the news is saying, we're seeing a resurgence. So stay safe.
Absolutely. We will wear your masks, social distance, and use Dask.
Exactly. All right. Thanks. Good night.
All right. Good night, everyone.
Good night.
Thanks, Lindsay.
Thanks again, Lindsay. Thank you.